In the last series of videos, we tackled the trigonometry problem where you're given a right triangle and you're given the length of one side and one of the acute angles, and you want to find the length of another side. In this series of videos, we're going to tackle a related but slightly different problem where we're given a right triangle where we're given the length of two sides, and this time we want to find the measure of one of the acute angles. It's going to be a very similar process, but there are going to be a few differences along the way, but it's nothing we can't handle. It's going to be skills that we built in the last module. So once again, I want you to print out the worksheet, and at the top of it, I want you to write down with your hand the following steps. You're going to notice the similarities with the previous set of skills that we did. So we're going to start off with the SOHCAHTOA like we did before, because we're going to want to use that to figure out which trig function we're going to use for the problem. Once again, we're going to copy the diagram of the triangle down on our paper. Then we're going to label the two sides that we know. The angle that we want to find, I want to label that with the Greek letter theta. It looks like an O with a slash through the middle of it. And then the two sides that we know, once again, I want to label whether they're the adjacent side, the opposite side, or the hypotenuse. And then based on those two choices, I want to figure out which trig function is the one that relates those two sides. Now I'm going to set up a function like we did in the previous problem, except that this time we're going to use an inverse trig function because we're going to be solving for theta and not for one of the sides. All right, let's take a look at a sample problem. So write this problem down in spot 1 in your notebook and go through the steps just like I am. So once again, in the top of the section, I'm going to write my SOHCAHTOA. All right, I'm going to copy the diagram down. This is the square root of 59. This is the square root of 86. And they want us to find angle Z. So this angle here is where I'm going to put my theta. So relative to this angle theta, what are these two sides? This is our hypotenuse, and this is our adjacent side. So which trig function relates the hypotenuse and the adjacent together? Hypotenuse and adjacent are both in the ka. So that is cosine that we want to use. So the function that we're going to set up is the cosine of theta is equal to the adjacent over the hypotenuse, the square root of 59 over the square root of 86. And so in order to solve this, we want to figure out which angle has this side ratio going along with it. And so the way we're going to solve that is using our inverse trig functions. So theta is equal to the inverse cosine of the square root of 59 over the square root of 86. Let me grab my calculator and we'll see what that's equal to. So on your calculator, the square root buttons might be in different positions. It might have, I've seen a lot of scientific calculators in the last week that have a little 2 in that wedge there. So that's not the greatest way to talk about the square root, but it's what we got. So there's the square root of 59 divided by the square root of 86. And so that's equal to that. And now I want to calculate the inverse cosine. So on some of your calculators, this is going to be its own button. On calculators like this, you can see that that's written above the cosine button in yellow, which means I want to press the shift button. Sometimes it's called the second button. And that way, I'm going to get that 34 degrees approximately has a cosine that's equal to that. All right, and in this problem, I want to round to the nearest degree. So theta is approximately equal to 34 degrees. Okay? In the next video, we'll look at 2 other examples, and I'm going to want you to pick up going through those steps as well. So if you've got those steps written down, you're just going to go through them step by step, and you're going to be a master of solving this style of trig problem just as easily as you were able to do the previous one.